So let's do the last problem here on the quiz review. They give us this information. They give us the diameter of a rope and then the breaking strength, like how much it can, I guess, carry per, like how many pounds it can carry before it breaks. It says use the statistics utility, that's a graphing calculator, to find an equation for the line of best fit to model this data. Right, so we're going to do that by going to our graphing calculator first. Right, so I entered the data into the graphing calculator, and now I'm going to go to Stat and Calc. Choose number 4, linear regression, and calculate. And once again, I'll take it out to 3 decimal places. Alright, so my equation is y equals 501.736x minus 2,153.178. X, my independent, was diameter, and y, my dependent, was breaking strength. So x is diameter and y is breaking strength. Okay. It says find the error in the values predicted. Error, that's residual, predicted by the linear regression model for the breaking strength of ropes with diameters 12 and 18. So we're going to go to our graphing calculator for this. All right, and we're going to practice what we did last class. So we're going to go to Stat and Edit. And what I'm going to do, this is where I'm going to go to the top of L3. I've got to be in the top of L3. And this is where I'm going to put in my equation for my line of best fit. And in the L3 column right here will be all of my predicted values. Then in L4, I'm going to find my residuals by taking my actual minus my predicted. So let's start by typing in our equation for our line of best fit, which we said was 501.36. Now, I don't want to put in x. I want to put in L1 because my x values are in list 1. So I need to put in L1 there. If you put x, you'll get an error. So 501.730. Oh, I missed a number. Let me go back. Here, 501. I thought I hit all the numbers I needed to, but I didn't. That's a very common mistake. 7, 6, and I hit L1. Okay, and then minus 2,153.178. When I hit enter, I'm going to get all of my predicted values. Okay. Then I'm going to go to L4, and I have to be in the top of a column. I can't be in the first space. I have to be at the very top. And this is where I'm going to find my residuals, or my errors, where I'm going to take my actual values, which are in L2. So I'm going to type in L2, and I'm going to subtract my predicted, which are in L3. So L2 minus L3, and I'll hit enter. And now I can answer the question that's on my quiz review, where it asks for the error for the 12 millimeter and the 18 millimeter. So I'm going to point right here on the calculator. The 12 millimeter error is negative 87.65. So I'm going to write that down on my paper. And then my error for 18 millimeters. I look here at my table, 18 millimeters, my error is 771.93. Very easy to do using a calculator. All right, then when I go down to my next question on my paper, let's go back and look at the paper. All right, so for the 12 millimeter, I wrote down the negative 87.65, and for the 18 millimeter, I did the 771.93. Now I'm at letter C. It says use the equation in part A, so the equation that we wrote here, to estimate the breaking strength of ropes. So these are predicted values. So this would be my predicted values, because it's breaking strength of ropes. And I want to do the predicted values for 13 and for 25. Now this is not going to be in my table, because when I look at my table up here, I don't have a 13 or a 25. So I'm going to have to actually substitute, and I have a choice. I can substitute the 13 in for X, and then the 25 in for X, or I can go to my calculator, and I can go to y equals, and I can put the equation in, where I put in the 501 x minus and then I can pull up the table that goes with that equation so that I can find all the values, not just the ones from my original table. Right, and when I go down to 13, I see my answer, so I'm going to write that on my paper. And then I'm going to have to scroll down to where it's 25. And I'm going to write that answer down. Okay. And I've got my two answers. I got those off of the table from putting it in y equals. And then the last question I have is, which estimate in part C do you think is more accurate and why? All right. I think that the estimate for the 13 millimeters is more accurate because it's interpolation. Because anytime you predict within the values you know, anytime you predict within the known values, you're more likely to be accurate than if you predict outside of the known values. You're more likely to be accurate than outside the known values. And that's mostly because most models, regression models that we find, are not always, they're not going to be accurate forever and ever. They're only accurate for, a finite amount of time. At some point, it's just not going to make sense anymore. So most of the time, we're going to say that interpolation is more accurate than extrapolation. Sometimes they're both accurate. But if we have to pick which one is more likely to be more accurate, it's the interpolation.